Welcome everyone to, I believe, the penultimate RSE seminar for this term. So today we've got Paul Sharp, who's come down from York and is part of STFC, and he's going to talk to us about Pydantic, which is a Python package for picky programmers.
Hey. So hello everyone, thanks very much for inviting me here. It's really great to be able to talk to you all today, and had a nice lunch so far. Not so nice train journey, but I won't blame you guys for that one. So yeah, welcome to Pydantic, a package for picky Python programmers. I was very pleased when I came up with that title. If anyone knows of a collection for cautious C coders, I'm all ears. So before we get started about all things Pydantic, I'll just introduce myself a little, if I may. And if I can turn the slide over, which, you know, you would think. There we go. So courtesy of this absolutely giant photograph here. So my route into RSE very much through the sort of research line. So I did a PhD in physics at the University of York, and then went into a bit of chemistry in the University of Liverpool. So I was a PDRA there doing crystal structure prediction and developing some software for that. And then for the last 3 and a bit years now, since 2020, I've worked at STFC. So firstly, that was a position between the scientific computing department and the super STEM, the electron microscope. And then for the last 18 months or so, worked as an RSE at ISIS neutron and muon source. And we do like to say the full name these days for slightly obvious reasons. So I've just mentioned a couple of the codes I've been a part of developing there. So ChemDash is the crystal structure prediction code from Liverpool, which is still going strong, which is really nice. There's been a couple of PhD students pick that up and take it onwards. InverSTEM is the EELS inversion code that I did with SuperSTEM, which is still to appear somewhere. And then RAT is the code I work on at the moment, the reflectivity algorithms toolbox. So here, just to give you a very quick illustration, is the ISIS headquarters. We'll keep going with things. So what we have over here, this sort of hill here is where the synchrotron is. And then we go into these 2 big buildings over here that are our 2 target stations. So we're sending very fast protons there. They hit the targets, generate neutrons, and then they spill out into this range of instruments here, which do all the different experiments that the instrument scientists know all about. As far as RSE at ISIS is concerned, we're sort of the new kids on the block. So the team was established just a couple of years ago, 2021. We've got 12 members of staff at the moment. And what we basically exist to do is to support the facility's staff and users in developing software that's actually, you know, usable and maintainable. We're all familiar with the notion of, you know, PhD student comes in, software gets written, next PhD student doesn't understand it, software gets thrown away, it's written from scratch again. Obviously, as RSEs, we all want to be getting as far away from this as possible. So we're trying to, you know, make sure that our software's, you know, an instrument, much like all of those very snazzy pieces of equipment that I was showing just before. And also, I've mentioned that we're looking, one of our sort of aims is to champion software engineering standards, which is sort of what the origin of this talk is, which was as a workshop to my colleagues. So they all learned about Pydantic, and then I've been picking up a few bits and pieces from them as well. So just a very quick illustration of a couple of the projects that we've got here. So the top left, which is neatly covered up by the screen sharing thing, is a screenshot from RAT, which is the code that I work on. So it does neutron reflectivity and uses the sort of a Beals layer model to work out what's going on with those. We've got SpinW on the top right here, which unsurprisingly is magnetic data that we're looking at there. Small angle scattering we have for SASView in the bottom left there. MDANS does molecular dynamics for neutron observables there. And I've got a couple more, basically pick the ones with all the snazzy screenshots. Dissolve is total scattering there, particularly for inelastic systems. We'll talk a bit about scans because I worked a little bit on that one. So this is a sort of virtual laboratory here. We've got a setup of the instrument Engine X there. So what this is for doing strain scanning experiments, you put your put a model of your sample in, you set up what the instrument's going to look like, and it will generate the all of the what's the phrase I'm looking for? Generate a script that tells you how you need to position your sample to get the kind of measurements that you want. It's proven very useful there. Fit benchmarking, just this last one here, compares different fitting and benchmarking type systems, as the name kind of gives away. I like showing off this one because it's a former York graduate who runs this project now, so keeping that York flag flying. So on to Pydantic then. So Pydantic is the most widely used data validation library for Python, and I would say the secret to its success is that it's powered by Python's type hints. You're not having to learn a whole new syntax here. You can use these type hints that you might already be using in your code, define the model in pure Python, and Pydantic does all the magic for you. And in particular, if you know data classes in Python, Pydantic shares a lot in common. You've got a big head start if you know those. So I've pointed you in the direction of the documentation there. As always with a new library, read the documentation. And Pydantic's docs are pretty good as well, so that's really good news. Probably the other reason it's quite successful as well. And I've just indicated there the full workshop that this is. So that is this slides plus some fun things to have a go at to see if you can use Pydantic yourself. The good thing with that is you get to run your own coffee shop. But I have been told that you have to provide your own coffee. So just to be clear there. Yeah, there were some very upset people. The developers tell you how many times Pydantic's downloaded, and the current figure is around 150 million times a month, which I think is absolutely staggering. It's a very lot of downloads. But not only that, that number, this is the 4th time I've given this presentation, that number's increased every time over the last 3-4 months. I saw a talk from Samuel Colvin, who's the lead developer of Pydantic, who was talking 9 months ago, I think it was, and we're only at about 50 million then. So it's really, really taken off. And you can see here, they demonstrate that Pydantic's used by this wide range here of forward-thinking, capable, cutting-edge organizations. The UK Home Office is also pictured. So when it comes to reading Pydantic code and writing Pydantic code, the first thing that we have to do is we have to summon our inner Sir Ben Kingsley, because we need to say version 2 or not version 2. That is the question. So the big development in Pydantic over the last year is that release of version 2 in June 2023. Now, always use version 2 code in Python. The reason being, there was a lot of break changes introduced, lots of changes to the syntax, to the methods, lots of new features. But what that does mean is that if you look up some examples, it's likely that you might find stuff that's written in version 1 and therefore is out of date. The documentation comes to our rescue again, though, because there's the migration guide, which is really useful. Every time I've seen something I've not recognized, quick search of the migration guide has shown up what it is and what you should use instead. The other big development as far as version 2 is concerned is that there's a big performance boost. So they say 4 to 50 times faster, depending on what you're doing. The big reason for that is they've rewritten a lot of the internal gubbins in Rust, and that's where they found the performance boost from there. So, as I mentioned already, Pydantic is based on type hints. So just as a reminder for everyone, Python, as we know, a dynamically typed language. So the type of a variable can change over the course of its lifetime, and it's determined only at runtime. We don't compile saying this thing's an integer, this thing's a float, and so on. So PEP 484 introduces type hinting. So when you're defining classes and functions, you can introduce a type hint to say, this is what I expect the thing to be. So we've got this example here with this very simple greeting function down here. So I've said that the first argument, the name, is a string, and it returns a string. And we can see it's just stuck 2 strings together to do that. But of course, these type hints aren't enforced. If I put hello 5 in, it'll try to do that as well. So it's really just as an aid to developers and for your IDE or for a type checker. So as I've mentioned again, no type checking happens at runtime. You have access to your type hints through the annotations attribute, but what the PEP here was assuming was that you have your offline type checker, so you'll run it through MyPy or something like that, which will do the type matching for you. So the other big thing in PEP 484 is introduce the typing module, which adds support for type hints, and we'll be making use of some of those routines as we have a look through Pydantic as well. That's the wrong way. That's the right way. So here's a Python class, hopefully something we're all familiar with, and use some type hints here. So I've got a very simple user class here. Then I've got the familiar constructor here. So I've got the arguments. So I've said the name of the user, which is a string, the age, which is an integer, and we've asked for the birth year as well, just for those people who go, no, I really am 18. Just make sure. And then, as is familiar in a constructor, we say something like self.name equals name, self.age equals age, self.birth year equals birth year. We assign the input arguments to our instance variables. And then I've got another greeting routine here, which returns none because it just prints hello and then addresses you by your first name. So next, I spoke already about data classes, introduced in PEP 557 and simplify the definition of classes. So I've defined the same class again. So I've imported the data class and I've got the data class decorator. And now for my user class, I've got the name hinted as a string, the age, which is an integer, the birth year, which is an integer. But you'll see now there's no init routine. When we have a data class, we get our constructor for free, and it's defined in the way that I showed on the previous slide. You assign the arguments that you put into the attributes. And then again, I've got the greeting function here, which is just written exactly the same. So when it comes to a data class, you have to put a type in for each field. They are compulsory at this point, but it can just be typing.any, which is, it could be anything. But the type hints are still hints. They're still not enforced. You can still put whatever you like in. As I mentioned already, we've automatically generated the init method, and we get a few others generated as well. So we've got the repr for representing the class, and then the comparison routines here. So we've got equal, not equal, less than, greater than, and so on. So I keep saying that the type hints aren't enforced. So now enter Pydantic. Now we can enforce those type hints. So you write a class that inherits from the Pydantic base model. What will happen is if you put something in that's the wrong type, you'll raise an error. And you'll see here, this looks very, very similar to the data class. I've inherited the Pydantic base model, no decorator, and I'm subclassing the base model instead, but everything after that is exactly the same. So here's what it looks like in action. So I define a user here who's got a name of 5, and then I got all of this nice error message here, including the key line here towards the bottom, 1 validation error for user. It gives you the field, the name, and it says that that input should be a valid string. So we'll have a quick look at how this works, but I'm going to take a minor detour first, if I may, and we go from the Prince of Denmark to the Emperor of France. So it was Napoleon who allegedly said that the English are a nation of shopkeepers. Now, I asked my brother about this quote. He's got an MA in history, and he said, whenever you get any quote like this, almost certainly it wasn't said by the person that it's claimed to be. So it's nice to know that just like in science, certainly in physics, as you go to history, the moment you get to postgrad, you learn every single thing is wrong. But notwithstanding that, I think that not Napoleon had a bit of a point. Because not only are the English a nation of shopkeepers, I think software developers are a nation of shopkeepers as well. Because when I learned about Pydantic, I saw a course demonstrating how you can use it by running an ice cream parlor. I saw a talk last year where somebody was explaining some software by running a fish and chip shop. What I remember from it is the presenter really liked place, and I was hungry throughout the whole thing. But that's about all. So, of course, as I've already mentioned, I was thinking, okay, if I'm going to present to scientists and software developers, then the choice is obvious, isn't it? We've got to run a coffee shop. So I've included the coffee shop menu for the Attic here, which was one of my favorite places in York. Sadly, no longer open. Thank you very much, global pandemic. But what I wanted to drive at is the way that you order a coffee here is that you choose some coffee beans via their country of origin. You choose one of these 4 methods that they'll brew the coffee. They'll make the coffee, et voila. So let's try and put together a model using this in Pydantic and see what we can do. So normally this is in the workshop where I challenge you guys to do it, but I feel like you guys want a bit of a chill out. So I'll do it for you and we'll have a look. So can everyone see some Python here?
Yep.
Excellent. Thank you to the voice of God there. There we go. Okay, so I've got a Pydantic model here. This is for my coffee here for the Sharp Coffee Residence, as I've decided to name my coffee shop. Get all of those things right first. So I've got a country that I'm ordering my coffee from, which is a string, a method, which is a string as well, the size of coffee, another string, milk and cream are bools because they're true or false, and an integer number of sugars that you can have. So I'll just import this. Remember the first part. So let's try and put one together first of all. So anyone got a favorite country?
Colombia.
Okie dokes. Have milk in our coffee? No. Okay. We'll have some cream in then, shall we? Because we'll learn how to spell first of all. We'll go all indulgent, I think. And how many sugars do we have? Are we all sweet enough? Is that it?
0.
We'll put 1 in because 0 is the default. So you can see now I've put those in. I've defined my class and I've got coffee and I've got the various things that we put in and everything else is set as their defaults. So far, so straightforward, hopefully.
There's some suggestions online for 0.5 sugars or -1 sugars.
We'll do all of those.
I had a suspicion we might.
So next up, I will go for, well, let's have those 0.5 sugars. Let's have some milk, not loads. Anything else that's complete nonsense?
Size, well, I don't know, 5.
5 equals 5. And what we have, unsurprisingly, are a lot of error messages. But the thing I want to draw attention to is you can see here that it lists 3 validation errors for our coffee. So it says that the size is wrong because it should be a string. It says the milk is wrong because that should be a bool and it can't work out what's going on there. And it says that the sugars are wrong because they should be integers. So we've put in lots of wrong things and we've got them all set out. Okay, let's try another one. I think I might have to take over on this occasion. So we'll say milk equals yes. We'll say, what else? Sugars equals 2.0. So they don't quite look right, but you'll see that they've gone in and they're perfectly fine. So the milk has come out as true, and remember the default is false, so it has been switched over even though we've put yes in, and the sugars has come out as an integer even though we put a float in, put a float that's convertible to an integer. So one other example that I want to show off, so we'll go for the famous country of Wakanda on this occasion, and we'll go for sugars of -1 as was suggested. So that goes in, and that's all fine. Wakanda is a string, even though it's a fictional country, not a real one, so it's accepted. And the number of sugars of -1 is fine because -1's an integer. So that was everything that I wanted to show. So I'm going to switch back over, hopefully fairly smoothly. So I invited everyone after they did this to ask what they noticed, but I've pointed out already, so hopefully we'll see it. So as I mentioned already, Pydantic gives you a list of the Pydantic validation errors for all the things that you did wrong. So you can see, hopefully, everything at once. The big thing, how you have some unusual inputs that are accepted. What Pydantic does is it will coerce the inputs that it gets into the right sort of type. So we saw float converted to an int, and you can do vice versa. You can have yes as a synonym of true, or you can just use y and triple your productivity. What we have, Pydantic has a guide to standard library types, so you can refer to that and that'll tell you how all of this works. But if you really don't like it, you can run Pydantic in strict mode and disable all of this coercion. I would just caution against that though. If users, they're a particular breed and they can get these kinds of things wrong, Pydantic's generally going to coerce things in the right direction. I don't think there's much gain in insisting that users put in 2 rather than 2.0 or something like that. But of course, as always, depends on what your needs are. And finally, as we saw, you can have some valid inputs, but not sensible ones. So trying to get your coffee from fictional countries or having -1 sugars, which everyone brilliantly anticipated, is something that's going to go slightly wrong. So we need to further constrain our model to try and make it work. So first up is the idea of multiple choice, when we've got a few different options we want to pick from. And we can go to the typing module again and use typing.literal to specify an allowed set of options for a certain field. So I've got the coffee shop here. So I've said that the country, for example, could be literally Tanzania, Ethiopia, or Angola. A certain African flavour to our coffee on this one. What we can also do, alternatively, is an enum. So we have the class of countries, which is a string enum here. Again, Tanzania, Ethiopia, and Angola there. And then we say that country is one of those countries, and countries.angola is default. Just as a sort of aside, Python 3.11 has introduced a new str enum here, which then puts it on sort of the similar footing as the int enum that's been defined in earlier versions. There's also a backport here called str enum, which works back to 3.6, I think. So my Python code at the moment is defining string enums a bit like this, trying to grab the 3.11 version in, if not using that. So we've got the literal and the enum. Which one should we use? Both do the job that we want. So the advantage of using literal is performance. They claim it's about 3 times faster. But, you know, if you're that bothered about performance to the extent that validating literals versus enums, maybe Python isn't the language for you, I'd politely suggest. And the advantage of enums, I think, a bit more compelling, is that you've got reusability throughout your code and between different models. So use whichever's best. So next up, we have the field function. Again, analogous to the field that you get in data classes. And what we can do is we can do some basic extra validation and customization of our fields here. So I've come back to our user model here. So we've got the base model and the field imported from Pydantic. We've defined what the current year is. So we've said that the user then, so we said the name is a string. So we've given that a default value of John Doe and a minimum length of 1. So you can't have a 0 length name. Age is an integer. That ellipsis there means that this is a compulsory argument. It's required. So there's no default. And fairly obviously, it has to be greater than or equal to 0. And then the birth year is an integer again, also required, and it has to be less than or equal to the current year. As I often have to explain, I'm not that kind of doctor. So there are a few different keyword arguments that we can use for our function. So if you have a numeric field, fairly obviously, as we've already seen, you can do the comparison operators, greater than, less than, greater than, equal to, less than or equal to. You can have multiples of, so a multiple of a given number. And if you so desire, you can allow inf and nan values in your numerical fields. When it comes to strings, you've got min length and max length, which define, obviously, the minimum and maximum length of the string. And for all you regex fans, we can do use the pattern to do some pattern matching and work out what's going on with those. For list inputs as well, min length and max length are also defined. And in that case, they refer to the number of elements in your list. And then just to sort of complete the picture, I've got decimal fields as well. Maximum number of digits and the maximum number of decimal places can be defined as well. So we can sort of tune things a bit further, but we can go further still. And this is where field validators come in. So field validators are user-written functions that allow particular further validation for individual fields. Now, these methods are class methods rather than instance methods because they're called as the model is being constructed. So what this routine has to do is either return the field that you're validating or raise either a value error or an assertion error. You can raise your assertion error with an insert statement or raise an assertion error, whichever you prefer. But it has to be one of those two because that's how Pydantic picks it up and records it in the list of validation errors that we saw earlier. Now, you can apply the same field validator to multiple different fields, but it only applies to one field at a time. So it only gets one field of the model, so you can't compare different fields to each other. So here's an example. So we're focusing on after validators here. what they do is they work after Pydantic does its validation and coercion. So we've got our user model once again defined in the same way. So our field validator here, we've got the decorator at field validator and the name of the field, this being the name field that we want to validate. We've got a decorator saying it's a class method. And then we've defined our function saying that the name must contain a space. So we've got the class, we've got the name of the field, which is a string, as we know from up here. And it returns a string because it's going to return the field. So we've said then, if there isn't a space in the field, we raise a value error saying that the name must contain a space and otherwise return the field. So then if we put in just the first name or just the surname or something like that, we'll raise this error through this validator. So this is looking good so far, but we can supercharge field validators a little bit by considering the world of annotated validators. Now these work almost the same as field validators, but you can reuse them between different Pydantic models. And they make use of the annotated function from the typing module to apply a validator to a particular type. So essentially you've made a custom type for Pydantic to validate against. So these custom types are set out in another PEP 593 here. So here's what an annotated validator looks like. So I've imported something extra here, the Pydantic.functional validators after validator here. I've got the routine that we use, the name must contain a space here, but it's not part of the class anymore. So it's just a field as the argument, which is a string, returns a string, and the code is exactly the same. Here's where we define the custom type for validation. So we've said a string with space is an annotated string, and it's annotated with the after validator, where the function that is the after validator is the name must contain space function defined up here. So then we come to the Pydantic model, we've defined our user model, and we've said name now, rather than its type being a string, it's a string with space type, which is defined up here. So what this means now is that if I want to come up with a different model and have something else that's a string with a space, I don't need to write any extra code. All I have to do is use that type again. So I mentioned that field validators apply for individual fields. The next thing is to think about what happens to the entire model when we want to consider a few different fields together. And this is where model validators come in. So like field validators, but apply to the whole model. And unlike field validators, though, they're executed after all the fields have been validated and the model is constructed. So therefore, this is an instance method. We have an instance of the model at this point. So the common use with field validators is we're resolving a dependence of one field on another. So we'll have a look at after validators again using this syntax here. So I've got our user model once again. So the model validator is indicated by the decorator here, and I've reinforced the default that the mode is after. So the routine that we're going to define, as you might have guessed from the other definitions, we're going to check that their birth year matches the age. So we've said if your birth year is not equal to the current year minus your age, or if you're later in the year, current year minus age minus 1, then they don't match up, and we'll raise a value error saying age does not match birth year. Just as before, we want to raise a value error or an insertion error for Pydantic to be able to spot what's happening. So that's where we are with all the different validators. So this is how we can construct all of these models and make them behave in such a way that we want. And then when it comes to using the outputs from these in our Python code going forward, we can have confidence that the fields are defined exactly as we want them to, rather than sort of hoping for the best as you might do in normal cases when you're defining a normal class. So the next thing to move on to is the model config, which is how we can apply sets of options to our model and work out what should be going on with those. So one of the things that the model config can do is it can automatically apply some of those field options throughout. So you can say string max length is 10, for example, and then every string defined in the model has a maximum length of 10. When you inherit a Pydantic model, it's worth knowing that the config is also inherited, and you merge in any additional options. And of course, you can contradict options in your subclass as well. So this is how the syntax for the model config. So you import the config in confdict in the first one. And then as the first line of your model, you say model config equals confdict, and then you've got those options there. What you can also do, which I quite like doing, is that you can have the config options as keyword arguments in your class definition. So I think this second way is the one that I prefer, although that's for me saying that having a few different options. I guess if you've got lots of them, maybe the first way might be more useful. But again, whatever floats your boat. So there's a full set of config options available, and I'd invite you to have a look at those. I'm going to talk about two that I found really useful, and they are validate assignment and extra. So validate assignment, when this option is true, now what the documentation says is it revalidates the model when any of the fields are changed. That is not right, because it's validate assignment. So it's whenever any of the fields are changed by assignment. If you change fields by mutation, then this doesn't apply. So it's very important to know. So this is really useful. And what it means then is if you've got the kind of model where you're going to be fiddling around with some of the options and some things might change over time, the model will remain defined as intended throughout its entire lifetime. But it can cause problems. Like all good developers, I discovered these problems by diving headfirst into them. So we'll go and do exactly the same here. So we're back to our coffee shop here. So I've got a model for customers of the coffee shop here. So I've got the base model and I've said validate assignment is true. So every customer has a name. They have the list of drinks that they've ordered and the number of people in their party. And because we're a really nice, friendly establishment, what we do is we give every customer a complimentary glass of tap water. So I've got a model validator here where we just add water to our customer. So we've got self.drinks plus equals number of people times water. So we've added water to that list. Now, you might be able to see the problem here because this looks a little bit like assignment. So if I instantiate a model, we call this validator, we reassign things, we revalidate the model, we go through again, we head into this validator again, and then we've got an assignment. So we revalidate the model, and this is what happens. You get a very big recursion error. So don't do it. Which way did that go? There we go. So as I already mentioned, it's validate assignment, not validate mutation. So the easiest way to change this is to change the way that you add to the list and say, okay, self.drinks extend number of people by water. I've now mutated the list rather than reassign to the drinks field. So I've solved my recursion problem. But can anyone spot the problem this time? We validate on assignment. That could be assignment to anything. So here's an example of something that I might do. So I've defined Paul as a customer who's gone in with a friend. There are two people in the party and they've ordered some tea and some coffee. So you can see we print Paul, there's no name there yet, but we've got tea, coffee and 2 glasses of water for the 2 people. Then what's happened is that the barista has asked my name at the last minute so that they can spell it incorrectly on the cup. And so we've now got Paul.name equals Paul, and that is an assignment. So we print Paul again, and we find that we've got 2 extra glasses of water. If imagine that one of my friends is running late and we up the number of people to 3, that'll put 3 more glasses of water on top of the 4 that are already there. We're not going to be able to enjoy our tea or coffee at this rate. So to avoid these problems, we have to think really carefully about what we do inside validators if we use validate assignment equals true. As we've seen, a good solution is making changes by mutation rather than assignment to make sure that we avoid those recursion errors. And also making use of logic, and so putting if statements in to say if something's changed in certain ways, apply this validator, and if not, don't do anything, that kind of thing. But what we can also do is use the model post-init routine to modify the model prior to model validation, and that routine will only be called when you instantiate the model. It won't be called when it's reassigned, revalidated on reassignment. So the model post-init, a bit like the post-init routine that you get in data classes as well. So I've got my customer model again, defined in the same way, and now instead of using a model validator, I've got the model post-init where the drinks are extended by the number of people times water. So you'll see now, if we go through the same routine we went before, I've come in as a customer with my 2 people and 2 drinks, and we've got 2 glasses of water. But now when my name gets assigned, we print the customer model again, and we have a name, and we have tea, coffee, and just the 2 glasses of water that we want. So the other thing I wanted to talk about then was what happens with regard to extra fields. If you throw extra fields into your model, how does that respond? The answer is it depends on the value of extra in your model config. So you have the options that you can allow, which is including any extra attributes in the model. Of course, it won't do any validation because you haven't put any validation in, but it'll just include what you've put in. You can forbid it, which means that you raise an error if there are any fields put in that are not part of the model, or you can try not to click. You can ignore any extra attributes, which is the default, which is just cast them aside quietly. So it's worth knowing if extra equals allow, then you have access in your model to those extra fields in the model extra attribute. So very quickly, we'll see how they all work here. So I've got a very basic user model here. The model config to start with is ignore, which is the default. So we've got a name of a string. So if we say that the user is a user with a name of John Doe and an age of 20 and print that, we just get the name John Doe, and that's all. If we have extra allow in this second example, then we'll user name John Doe, age 20. We get the name John Doe and the age 20 included in the model. And finally, if we have extra forbid, then we'll try defining it, and what we'll get is a validation error, one validation error, and it'll give you the age, which is that extra field you've put in, and say extra fields are not permitted. So I'm going to brave having a look at some Python again, but just to show a few of these features together, I've got a simplified version of a model that I have in RAT, and we can see how the kind of thing works. So what we have here is a data set. So you put in some data and you say, I'm interested in this X region of the data that I'm going to try and fit a model to. So let's see what happens, shall we? So I've just got some test data that we've got here. So here's my fitting data model. So we have a name of the data set, which is called data set to start with. Data, which is a NumPy array. So we have this in the model config, we have this arbitrary types allowed equals true, which allows us to use types beyond the Python standard library. And we've got X range, which is a list of two float numbers, empty by default, but both its min length and max length are 2. And what we want to say there is we're considering the X between X1 and X2. So you can see here on this data, I've got the numbers 1 to 10 as X and the square and X squared as Y. What you can say is, okay, I put this data in, but I'm interested in 4 to 6, for example. So for that, I have a field validator, which deals with the data and checks the dimensions of that data. So we check that we have 2D data, first of all, and raise a value error if not, and then check that we have two values. So we have a set of XY pairs rather than anything else. We check the X range here. So we check the minimum and maximum here. We need to make sure that the minimum is less than the maximum, and we raise a value error if not. We've got a model post in it, because if you supply some data but don't supply an X range, then the default, remember, is an empty list. But we don't want an empty list. What we want is the entire extent of the data. But of course, we don't know that beforehand, so we can't put that in as the default. So this is where the model post in it comes in this case. So we say if the length of the data is greater than 0, then the data min is the minimum value, the data max is the maximum value. And then if X range is not in model field set, so the model field set attribute is all of the, as you might guess, all of the fields that were set on initialization of that model. So you can always say in your validators if you've set this thing or if you've not set this thing. So we're saying if we've not done it, then extend the X range with those two values. And then we've got a model validator at the end here where we check the ranges. So then this is the case where we have supplied some X values and make sure that they're in the actual data and raise errors if not. Right, so what I'll do is I'll leave it there for now. I'll let you guys ask some questions, and then I'll see if I can get this into life. And I will try and put the summary back up, but for the sake of it not taking an hour, I'll say thank you very much.
Thank you very much, Paul. That was really interesting, and I'm tempted to inflict the Pydantic hammer on my open source contributors.
What have I started?
Does anyone have any questions either here or online? Mirren?
It's just a matter of opinion. Do you think this should be in a future, features of Pydantic should be in a future version of Python? Like part of that?
I've certainly seen the conversation happening, yeah. Whether it will happen, I've no idea, but I think there are certainly quite a few people who think that this would be something that's a really good idea to include. Certainly speaking to the Castep developers in York about this, was saying it feels like this is, getting Python code to behave properly and feel quite a bit more robust by putting it in this sort of guise rather than what we're all familiar with. So it may well be on the cards. I'm not expecting it imminently, but there are people who share that view, definitely.
Is there anything that doesn't work with Pydantic? So overloads or abstract methods probably do, but is there anything you've come across that doesn't play well?
So not anything I've seen has been too tricky. I mean, we've sort of scratched at the surface of some things here because with everything I've presented, I've talked about after validators. You get before validators as well, which act before Pydantic does its stuff. The reason that I don't worry about those is they're a bit trickier, and the main reason that they're trickier is because you've got to account for the fact that the input can be anything. And so you've got to navigate that. So the phrase in the documentation is that they're very powerful and flexible, but can be cumbersome and error prone to implement. So that's something to watch out for. But if
that's legally for don't touch.
So that's one thing, certainly. I mean, the big thing I've had to do, we talked about validate assignment, which I've used. So what I wanted was a validate mutation option as well, because we had lists of fields and we want to make sure if people were fiddling around with those lists that they were still behaving as they should be. So I had to write my own snazzy code for that one. So we were able to do it by basically forcing revalidation whenever the model does anything at all. It's pretty much how we ended up doing it in the end. So I think, yeah, on my feature request, if they could put in a validate mutation alongside validate assignment, that might be quite nice.
How does this compare, like, to MyPy? So, like, MyPy does like checking. This looks like that on steroids.
Well, yeah, I think that's certainly some of it. Of course, MyPy does its type checking, but it's not doing it at runtime, and you can't reevaluate as you're going on with the validate assignment type options. I don't think, can you? So it's that on steroids. I think is not a bad way of putting it.
And then my other one's more of like, I don't know, comment or concern. It's like it scared me a little bit that the type checking library adds logic to the code. For instance, I know you showed it as like an example, but you added 2 waters right to the person's order.
Yeah.
But in the type checking part of the code, right? So I wouldn't expect like application logic or my code to be doing stuff in the what I would consider the type checking part.
So yeah, I think that's fair enough. So I think first to say that is in that part of the code, that's the stuff that you're writing. So you can say, I don't want this kind of thing here. This is a bad idea. And so that's something that you can decide for your own project is certainly one thing. The other thing is that Pydantic go quite a bit into what is and what isn't a validation library, and they'd argue that they're not a validation library. The reason is that they say by the strict definition, validation is where you say, make sure that the inputs are what they're supposed to be. And what Pydantic does in their philosophy is saying that take a set of inputs and produce an output that fits the criteria that they want. So this is where coercion comes in, for example. You put in a float thing for a thing that's supposed to be an integer, and it'll produce an integer value for the field for you. So from that philosophy, I think it feels a little more reassuring putting those kind of bits of code into the validation, as it were. But yeah, that's something to consider as a developer, I guess.
I have a couple more questions, but I think I can see a bit more boring of your presentation. Finish off there. But yeah, we'll go and get a coffee and have a chat. Other than that, if people can just join me again in thanking Paul.